Listen to the music. Read the text. Think about the picture. Where is the person here and where is there none? Is there something human here or not at all?
But imagine a future where you could read a book while a computer takes the wheel.
It was another training trip for Dean Pomerleau's unusual car. The car was one of the first attempts to create an unmanned drone, stuffed with some of the most advanced, albeit bulky, electronics at the time. The car could be controlled without human guidance. Before crossing a bridge, Dean let go of the wheel once again, handing over control to the car. Suddenly, the car sharply veered to one side. At the last moment, the inventor managed to get the car back on track, just a meter from the abyss. Back at the laboratory, Pomerleau tried to understand the computer's mistake, or more precisely, the proto-neural network's mistake. It was not controlled by an algorithm, but a self-learning program. The network was using the grass at the edge of the road to determine its direction, hence the appearance of a bridge confused it. In this instance, the driver survived. 30 years later, the outcome was more tragic. 2022, China. A Tesla suddenly went crazy. It hit a cyclist and a pedestrian. They died. The manufacturer stated that the human factor was to blame, and the driver confused the gas with the brake. But in Chinese social networks, they claim that for the last mile and a half, the owner lost control of the Tesla and the car moved and accelerated itself. We're afraid of the dark, we're afraid of the unknown, but our greatest fear is that of the unexplainable, of that which we created ourselves but can no longer understand how or what it is thinking. It's fine to fear doomsday when it's somewhere far off in the future. And what if this day has already come and no one noticed? It's just that in 2015, everything was more prosaic. No walking robots, just an old board game, and the human intellect that preserved long before the neural network.
포기할 것 같습니다. 여기까지입니다. 여기까지입니다. 여러분.
네.
여기까지입니다. 예.
You wrote the code, you'll be replaced. You're a logistician, accountant, loader, taxi driver. Neural networks will do your work faster and for free. You're a broker, investor, crypto trader. You won't be needed in 5 years. Or maybe you're a designer, journalist, marketer, specialist about promotion in social networks. Change your sphere now. This video was created by the Sumsub verification platform, but more about Sumsub in a bit. Learning algorithms were named neural networks based on an analogy of the device with the human brain. The complex interactions of neurons in our head somewhat resemble the principal workings of the networks. We won't go into detail about how AI works, or we'll be here for hours. Here are some videos that outline the key principles of machine learning. The main point is that the network consists of several levels, external and hidden. It analyzes incoming data and learns to find the necessary patterns in them. Patterns are analyzed in deep layers and the network will then give a result. Algorithms can help perform routine, straightforward tasks which a human would do slower and less accurately. For example, fast and complex calculations, but the script will be stumped by more subtle questions that wouldn't cause us any problems. For example, telling the difference between a dog and a cat. A neural network is a learning algorithm that knows how to gather intelligence. It doesn't just execute a command. It learns from large amounts of data to understand the main gist and predict a result. After pulling the lever, the ball rolls around inside the slot machine, bouncing off obstacles, and knocks out points. Some just randomly pull the levers, others calculate the strength and timing. But nonetheless, there is an optimal force and trajectory that will get the most points. In theory, a person can find it intuitively. But the neural network will need to be allowed to play this game many times, and in turn, it will learn to calculate the trajectory. Perhaps, even by the next iteration, the network won't choose the most obvious path, but it will again be the most effective. The human eye will not see logic in this Brownian motion, because, again, it doesn't exist in the human understanding. There is only the result. The problem is that instead of the glass cover of the slot machine, we have a black impenetrable box. Probably for the first time ever, people have created a mechanism whose principal mechanisms they do not fully understand. It's like looking through water. The first few meters, it's transparent, and then darkness. Look at your smartphone. You probably have a modern version of the gadget. Take any picture, something completely random. And that fraction of a second that the image turns from cloudy and overexposed into clear and stabilized is all the time that the 2 or 4 neural cores of the smartphone processor need to process and improve the image. Most often, there is not enough information in the pictures. The neurocore understands, for example, that there is no focus on the face in the frame. And it sharpens this fragment of the photo, almost as if it fills in the missing pixels. It understands exactly what needs to be improved or completed thanks to the millions of pictures that it had already studied. Here's the latest smartphone from Google, the Pixel 7. It can make sharper not only photos taken on the device itself, but any photo at all. And here is an equally impressive service that can improve the quality of even the most ancient photos taken at the beginning of the 20th century. On the Library of Congress's website, there is a selection of the first pictures ever taken in the United States. Let's see how a neural network can improve this photo. This picture was taken in Alaska in 1868. It's a group portrait of representatives of a local tribe. Their faces are fuzzy. Let's hand this photo over to our neural network. The difference is obvious. The specialists of the very same Google Brain team have trained a machine learning model to turn low-resolution photos into high-resolution detailed images with almost no loss of quality. It uses an interesting method. The low-quality image is mixed with digital noise, more and more noise to the photo until the picture is obscured altogether, turning into nothing. And then the algorithm reverses the process, gradually removing noise from the image, guided by the original low-resolution picture. So it's almost as if the neural network seems to understand or even know which pixel or which exposure this or that part of the photo should have. There are different variations of these networks. For example, CDM, which was trained on more than 14 million high-resolution images. CDM works cascadingly. That is, first it generates a low-resolution image, which gradually increases to the maximum possible. According to Google, an image with a resolution of 32 by 32 pixels can be enlarged up to 256 by 256 pixels without significant losses, that is, 8 times. An image with a resolution of 64 by 64 pixels can be completely scaled up to a resolution of 1024 by 1024 pixels, 16 times. The same principle applies to videos. Neural networks help to remember your face-for-face unlock and optimize the operation of applications. Ungrateful is what the developers who have been trying to teach machines to understand our speech for almost 100 years would say. This was the first mechanism that could respond to voice commands. Created in 1927 in the USA, the Herbert Telecox robot was a simple device in which various relays reacted to sounds of different frequencies. There were 3 tuning forks in the robot, each of which was responsible for its own tonality. One of the relays was turned on, depending on which tuning fork was triggered. It was possible to communicate with the Telecox robot both by individual signals with the help of a whistle and by short verbal cues from tuning forks laid out in a sequence of sounds. Not so long ago, the height of this technology was a visual interlocutor capable of maintaining a long conversation with scientists in large laboratories. Now, neural networks live literally in your home.
Alyssa, what time is it? What the hell is wrong with this blasted thing?
For example, You can actually see how well neural networks can pass the Turing test on this website. This neural network for talking to people was written back in 1988 by British scientists. The number of chats it has had over the years has exceeded 65 million. Neural networks can paint a picture just on a few given words. Just type in the necessary hashtags. The new network Midjourney works wonders, combining different characters in one picture, essentially writing works of art. Here is the story of a man who rose to popularity thanks to neural networks. He just became Tom Cruise. This naturally raises the question, why film the real Tom Cruise if his famous facial expressions can be recreated by artificial intelligence? Or are they already doing this?
I mean, how do you answer that? How do you answer that question?
Did you notice that Tom Cruise in the new Top Gun barely differs from his character in the original film shot 30 years ago? As technologies become more accessible, soon pretty much anyone will be able to create a deepfake. Therefore, we'll face more and more criminals abusing this tool to steal money, identities, and more. This begs the question, how can we detect all these fakes when they're getting so realistic? Well, Sumsub again has a solution for that. Our in-house liveness technology enables companies to detect criminals using deepfakes to register. Our liveness is a superior artificial intelligence technology with 7 years of training data. It detects even advanced forms of deepfakes and other tricks used by fraudsters. The solution uses people-friendly facial biometrics that work equally well across the globe. It takes just 2 to 4 seconds for authentic users to complete the check, resulting in pass rates as high as 99%. Plus, our liveness solution has been proven secure by iBeta tests. How can you implement liveness? It suits a variety of use cases, such as biometric verification. For example, when you need to compare the user's face with the image on their ID. You can also use liveness to detect duplicate accounts, for face authentication during logins, or to confirm risky actions. If you want to learn more about our liveness technology, see the link in the description. This way, you'll stop all those fake Tom Cruises attacking your business. This little rover is carrying a package. Most likely, he took it from one of the automated warehouses. There, logistics is also probably controlled by algorithms and neural networks. Our self-driving car, when it happens, will be electric, largely automated, and surrounded by AI, including facial recognition. In China, 80% of all jobs can be replaced by smart technology. In China's economy, demand is not limiting jobs and resources. Instead, demand is increasing by leaps and bounds. For example, Smart China 2030. Making it real, smart infrastructure includes building smart cities. Their AI systems will determine whether and where parking is needed, letting drivers to rest. We didn't notice that we have ended up in the paradise described by science fiction writers. Artificial intelligence takes care of boring, tedious work, freeing up time for humanity to be creative. But is it truly a paradise? PricewaterhouseCoopers, one of the largest consulting companies, released a study titled, "Will Robots Really Steal Our Jobs?" And the forecast is unsettling. Yes, algorithms will take work away from many, and those first in line to lose their jobs will be physical laborers, couriers, movers, taxi drivers, factory workers.
Break the device and smash my switch up!
Perhaps we will see what the British saw in the early 19th century, Luddite riots. Then, too, a technological revolution broke out, which fundamentally changed production. Technological progress meant that one machine began to perform the work of dozens of low-skilled workers. The Luddite movement became huge. They raided workshops, smashed up new planters, and steam-powered spinning wheels. It's easy to imagine a burning data center in the background of a crowd of newly redundant workers chanting. According to the estimates of PwC, 37% of workers already express concern that artificial intelligence will replace them. And yes, blue-collar workers will obviously be the first ones to suffer, but it will be worse for those with a desk job.
It's not a question of enough, pal. It's a zero-sum game. Somebody wins, somebody loses.
Do you remember how Gordon Gekko made money from insider trading, which is totally illegal for a trader? But now imagine that you were guided by events on the stock market, and it's absolutely legal. Okay, robots have been trading on the stock exchange for a long time. Well, algorithms. In fact, 4 years ago, 80% of transactions were made by robots. But AI works differently. Depending on how well the network is trained, it can predict market changes. Conditionally, technical analysis guarantees that the peak has been passed, and it's necessary to short. But a neural network suggests that the volatility is such that the growth will continue, and will continue exponentially. Don't sell, wait. And often artificial intelligence turns out to be right. According to IHS Markit, in 2018, the results of the use of AI by financial organizations was estimated at $41.1 billion. By 2030, this figure could reach $300 billion. That's what neural networks pick up the fastest. That is, how to do the work of a clerk and copywriters of all kinds. A truly exclusive product is created in units of one in the engineering, financial, and creative fields. The essence of the rest of the work is often a copy-paste or compilation. That is literally what AI was created for. Of course, people in their own selfishness will be sure for a long time.
Can a robot write a symphony? Can a robot turn a canvas into a beautiful masterpiece?
Can you?
But the reality, and we're talking about genuine reality and not futurology, is that this is all they can do. Yes, while 1,000 neuromonkeys sit behind thousands of virtual typewriters, they cannot write War and Peace. As a rule, the network can't maintain a storyline for a long time, and on the second page, it forgets about the heroes that it described on the first. Although people have been attempting this for a long time, but nonetheless, a piece of text, a short post, a sales article are all well within the capabilities of the neural network. As for neural networks in music, well, that's easy to talk about. There are dozens of shareware engines on the web that compose tracks for which no one needs to pay royalties. For example, ampermusic.com. We've composed a few of our own. It's not Mozart, but for the voiceover of a video script written by a neural network on YouTube, it's good enough. By the way, are you sure that the text you're listening to now is written by a person? Write your thoughts in the comments. Okay. Composing music, inventing advertising slogans, and organizing logistics. Most people fine with entrusting this to the god from the machine. But what about trusting it with your life? Already, learning systems are helping doctors to make diagnosis. So far, everything sounds logical. Many stories of diseases and specific cases have already been digitized and entered into databases.
So idea was to develop autonomous intelligent system that can take all that data in real time, process it, and then predict risks or complications, not just one time, but on multiple occasions.
It's also not difficult to teach the network. Simply download a large amount of data and diagnosis and identify connections. And then any diagnostician can use AI as a tool. The accuracy of these neural networks is only increasing. A few years ago, they had an accuracy of 87%. A good doctor will correctly diagnose 86 cases out of 100. Now, it's up to 97. Atlas, Advanced Targeting and Lethality Automated System. Can you think of a worse name? And even the explanation, autonomous target acquisition technology that will be integrated with fire control technology, aimed at providing ground combat vehicles with the capability to acquire, identify, and engage targets at least 3 times faster than the current manual process. Didn't make the situation much better. As soon as information about the development of this automated killing machine got out to the public, a scandal ensued, and the military had to explain that, no, artificial intelligence will not decide for itself who to kill on the battlefield. This system was to help soldiers, but they will still need to pull the trigger themselves. Have you ever seen salmon in the wild? A neural network was asked to draw a picture of salmon swimming against the current. This is what happened. Meta AI and Papers with Code have launched a demo version of the new Galactica language model based on a neural network. This system was designed for storing, combining, and analyzing scientific knowledge. However, the system was shut down a few days later. Users started generating content with racist and offensive content, as well as creating articles that resembled scientific research, the content of which could lead to potentially dangerous consequences. Now the neural network is never wrong. It gets results based on the data it was trained on. And if a person doesn't like the results, it's not the AI's problem. And the greatest technical and ethical task will be to create a system that would ensure against AI making decisions that might be harmful for humans. Have you seen this picture before? It's called the trolley problem. Save many but kill one, or vice versa. Many will die, one will survive. A difficult choice that the person taking the decision will think about for the rest of his life. And now think about Tesla in China. The algorithm, the neural network is devoid of morality. So how can we trust it with making vital decisions? And most importantly, who is responsible for the damage caused by artificial intelligence? Let's imagine in the near future that we have fully automated taxis. You call a taxi, and before you sit down, you have to agree to the terms and conditions, just like how you accept cookies on websites. But you are agreeing that the car is driven by one or another AI. This means that you understand and accept the risks. Probably, there will start to be a hierarchy. Someone will never get into a taxi under the control of a neural network of a certain manufacturer. In the same way that at the moment, some people refuse to fly on Boeing 737 MAX due to the fact that 2 planes crashed due to design errors of the manufacturer. But okay, with cars, you can come to some kind of solution. But what about neural networks in medicine? Networks can already predict the development of dangerous diseases. What if the network recommends that a woman have a mastectomy, since she has an 80 to 90% chance of breast cancer? And let's say that the patient follows this advice, only to later find out that the neural network was taught using outdated data, and the operation wasn't necessary at all. And the prediction of crimes? Criminal records are already being digitized in large volumes. You can teach a neural network to identify those prone to relapse, a certain social group, patterns of behavior. This is just one step away from the Minority Report.
The great Oz has spoken. Oh, pay no attention to that man behind the curtain.
Who will be the judge? Maybe AI will make the decision. This is what the first meetings under the leadership of artificial intelligence in China look like. And in Estonia, the use of neural networks is already being introduced into judicial practice. To be honest, it's starting to sound a little scary. Not because it resembles the scenario of a bad dystopian movie, but because of what was talked about at the very beginning. That feeling of the unknown. A black, opaque box. XAI, Explicable Artificial Intelligence, is a neural network in which there is a special block that explains how the network made a particular decision. This approach is called a white box. Most likely, this is the future of AI. At any moment, a person can pop the hood and see what's happening. Well, like in a pinball machine. Paradoxically, the advent of the era of neural networks will, of course, deprive many thousands of people of work. But on the other hand, a lot of new positions will appear. Developer will be the profession of the future. Teaching the network is an art. You need to correctly understand the goals, understand the coding, and at the same time be a narrow specialist. A marketer, a journalist, a musician. No need to smash up the automated planter. It's not a replacement for you, it's your new tool. By the way, have you noticed that artificial intelligence has been adding its own touches to this video? If you did, pause the video and tell us in the comments how you spotted that the content was of artificial origin. Man had a similar experience once, a long time ago, when a new technology, the principle of which people did not fully understand, could both help and kill. It was fire. Several millennia later, and he was understood and tamed.